Okay, now let's start with event.c. Again, event.c is event.code. That's the literal description of what you have seen in event.h. Here, as you can see, the include part, I'm including here the studio.h, standard input output, standard lib library.h, and what is this? Event.h. What is the event.h? It's the one that we just wrote. Um, if you notice here, the studio.h is written between two brackets like this. Same with the stdlib. However, for the event.h, it's written between two double quotes. The reason is that the studio.h and the stdlib.h exist in the library directory of the language, okay, C language. However, the event.h exists in the same directory that you have the event.c is in. It exists in the exact same directory. That's why you write it here. If you copy this file and put it inside the library directory of the C language, which is something I don't recommend, but if you do, then you change those codes to be the less than and greater than, okay? Now, if we go back to the H here, all right, you will find that here we defined the functions. So the name of the function, the return type, and the input parameters for each and every one of them. Now in the C file, we are describing the code of those functions, as you can see. So create event, what does it take? It takes the process ID as an input, the type, the event type, the event time, when will it happen, and the processor ID. All what that function does is create an event, and I'll talk about it now, and then assigns the event data and returns the event. How would we create it? As you remember from C, we have two kinds of variable creation / allocation. We have the static and the dynamic. The static allocation, you say event E, and that's it. If you do that, this will be stored inside the stack of the computer. A stack is a very limited memory. It doesn't have enough space, and therefore, if you expect many events to be created, which is the case in an operating system, then this, having it in the stack, could slow down the execution of the program, and you could run out of memory, okay? So in order to do it right, you need to put it in the heap. What is the heap? It's all the memory you have, huge amount of memory. How would you put your variable in the heap? By doing it as dynamic allocation, a pointer. So here I created E as a pointer to event, and then I say memory allocation, malloc. Because we're using malloc, this is why we had to include the studio.h, as you can see here. See here the studio.h. Studio.h as a library is required to be able to use the malloc function. What does the malloc function take? It takes the number of bytes that you need to allocate. I need to allocate number of bytes that is enough for a variable of type event, which means the size of event. So malloc will take the size of event and will return block of data, okay? That's what's gonna be returning, a block of data. This block of data, I want to shape it. So you have to do what we name it in C or any other language. explicit casting. So you say this block of data that you created, of bytes that you have created, put them as event, okay, and make a pointer to it, and you assign this E. When you do this, what happens is the compiler will go to the heap, create you an event in the memory like this, and returns the pointer to it. Okay, it will return a pointer to it. All right. After you create the E, you say that the PID that is being passed, put it in E points to PID. What does this mean? See, when you created the event, you know that the event is built out of 4 variables. Okay, so those are gonna be the 4 variables. One of them is gonna be the PID. Let's say this is the PID. This is the event type. This is the time. And this is the processor ID. Okay, so you want to say, you have here E pointing at this structure. So you want to say E points at PID. So you want to put the PID here. So that's how you say it. E points to PID equals, and then the PID. What is the PID? It's the variable that's being sent to create event. Same with the type, same with the time, and same with the processor ID. When you fill those data in, now you return the E that have been defined. In order to print the event, you send the event that's going to be printed. I always use pointers in C. This is my preference, and the reason is that when you send pointers, things are going to be much quicker, and you're not going to be filling memory with unnecessary stuff, because if you send it as called by value, you are literally creating a copy, which means occupying more memory. But when you send the pointer, you're not sending a copy. You're not creating a copy. Okay, so I'm saving a lot of memory, which makes your program much faster, as you will see in later chapters in OS. See, learning OS, by the way, will make you a much better programmer, because you understand exactly how things work in the operating system. So here, what am I printing? I'm just printing a line, for decoration. I'm printing the event type as a string, and I'm calling here something called interpret event type. I told you about it in the H file. I'll explain it again. What does this do? It changes the type, which is a number like 1, 2, 3, 4, into string. So it will tell you 1 is arrival, 2 is, let's say, dispatch, 3, and so on, okay? And I'm also printing here the process ID here. I hope you remember how printf is written. If you don't, here it is. I'm also printing the time of the event. E points to time. I did not print here the processor ID. If you want, you can add one line for the processor ID. Here is the interpret event. Look at that. I don't know if you know that, but we have something called switch. I hope you actually studied that in C, right? I actually say that T is admission, which is named arrival, right? If it's arrival, I'm going to say it's arrival here. If it's IO request, I'm going to put it as a string IO request, and so on. What is this switch? You switch the type and you say case this, do that, and it has to be followed by break. I'm going through this quick because this is not a C course. I'm just reminding you with what you have studied before. So here is the arrival, the request, the IO complete, the time expire, interpret, exit, dispatch. Here it is. I'm changing the enum elements into actual strings, and then I'm returning the string as a T, okay? Comparing the event, I'm sending item 1 as void pointer, item 2 as void. Why void? You will see it later when I explain the linked list, okay? But because they're void, I have to put them back to event. How would you do that? Typecasting. So I'm saying this void, which is item 1, return it to event pointer and put it in E1. This void, item 2, convert it to event pointer and put it to E2, and then I'm returning. Look at that, E1 points to time minus E2 points to time. What does it mean? If you remember the compare event, I told you it returns 3 values, positive, 0, negative. It returns positive if the first one is greater than the second one, 0 if they are equal, and negative if the first one is less than the second one. Okay, I'm comparing based on time, and that's it. So I'm saying here E1 points to time minus E2 points to time. So if this is greater than this, it would be positive regardless what the value is. If they are equal, it's going to be a 0. If this is less than this, it's going to be negative regardless what the value is. So the minus works great when you compare events. The last function that we have seen is copy event. I want to take the data of the source, put it in the target. So basically here I'm just making a sanity check. If the target is null, then I create it. So target equals the malloc again, if you remember. Okay, and then I put the PID of the source in the PID of the target, the type of the source in the type of the target, and the time of the source at the time of the target. You would tell me, but you did not return it, correct? Because it's called by reference. Since you are sending it called by reference, you don't need to return, right? Again, if you don't remember what called by value and called by reference are, please, you need to revise that in order to understand the code of the kernel of the operating system, okay? Now we're done with the event, and the next recording is gonna be about the process control block, PCB. Thank you.